Question is that you can't. So you all see that I have a function times a function. And I've got another issue where I have a function in a function. Right? So whenever I have a function in a function, it's automatically the chain rule. But when I have a function times a function, it's automatically the product rule. I have to do both. And I want everyone to listen up carefully. I must do the product rule first, because it involves derivatives within it. Okay? I must do the product rule first. Okay? So, when I do f prime, and here's, we're going to have good work, and these are going to get grosser. So if you're saying, well, I know how to do it, the notation's messing me up. The notation is very important. Okay? So, it's going to be the first function. I'm just going to put times the derivative of the second function. So I haven't actually taken any derivative yet. I'm just writing that I need to. So I'm going to follow that. Yes? No?
Yes.
Okay. Plus the second function times the derivative of the first. So once again, I haven't actually taken a derivative. I just wrote that I need to. Because, let's work on this derivative. I have to use the chain rule because it's something other than cosine of x. So what is u? 4x. So what is f of u? Cosine of u. That's u. You left the cosine u. So, f prime u prime. What is f prime? Negative sine u. What's u prime? 4. So my derivative, and I'm going to clean it up and plug it in at the same time. Negative 4 sine 4x. Right? Plug back in for u. Yeah? So that's just this. That's this derivative. Now I'm going to go over here and find this derivative. What is u over here?
3x.
3x. So what's f of u?
2 sine u.
2 sine u. So my derivative is f prime u prime, according to the chain rule. Now what is f prime?
2 cosine u.
2 cosine u. What's u prime?
3.
3. So I'm going to have 6 cosine of u, but I'm going to plug u back in, is 3x. Okay, now I'm going to go back and rewrite my derivative. So I have 2 sine 3x times negative 4 sine 4x plus cosine of 4x times 6 cosine of 3x. Now, this is where our identities might come into play. Not so much in this one, it doesn't look like. But these constants I definitely want in front. That's negative 8 sine 3x sine 4x. Plus 6 cosine 4x cosine 3x. And actually I could clean this up a little bit using an identity. Because doesn't that look a little familiar if I switch the order especially? Cosine 4x, cosine 3x.
What as you subtract?
Huh?
What and plus? Like there's your plus.
I mean plus.
Can you add signs? Isn't that what? Or add cosines? Isn't that what you do?
You can't add cosines if the insides are different. But we do have an identity cosine 2x. Or I'm sorry, cosine x plus y. Yes, doesn't that start off with cosine x, cosine y? Minus sine x, sine y. So this does actually condense a little. It's harder to see. So here's the point where, once again, if I'm checking answers in the back of the book, you might be okay. You might have found a perfectly good derivative, but it may look different. Okay, we're getting into that real territory. And I'm not talking a couple, I'm talking a lot of them.